Actually, I'll be talking about events, and this is a topic that is really interesting to me recently. And I found that other people feel the same. And you have a lot of resources about building system using, for example, event sourcing, which is a mean of using events as a main source of truth in your application. You can find a lot of resources that describe how to build microservice architectures using events and how using events make these services more decoupled. And you can have a lot of different message queues and event stores. And this whole approach is basically amazing with Erlang, Elixir, and OTP. But then I started to wonder why I really like events, and understood that this is not the point. This doesn't matter if you have some message queue. It doesn't matter if you have this event processing asynchronous or not. Because, you see, I work at a company called AppUnite, and we've been using Elixir for more than 2 years now in different projects, both small and large. And of course we love Elixir because it makes our code much better and much cleaner. And you often hear that because Elixir is functional, you don't have this additional complexity of OO languages. So you can often hear or read that in Elixir you don't need any patterns because it's just modules and functions, right? But then I looked at the code of the project I'm working on, and I used the new mix xref functionality that allowed me to basically render a graph of dependencies between the modules. And I saw that. And this is actually not the whole thing, because the whole thing was so big that it didn't fit the screen. It's about a half of one of the applications in our umbrella, and we have like 15 of them right now. So it's messy, and maybe it's our fault. But you see, building software is quite a complex task because it requires not only a lot of technical skills and technical knowledge, but you have to really understand the domain you're working with. You have to communicate clearly with your teammates, with the clients and the users. And to be honest, we are not so good at communication as developers mostly. But even though building systems is so hard and so complex, it turns out that changing existing software is even harder, because we make all of these assumptions about what are the problems, what are the way that we are going, and what are the goals. We think we understand our users and our clients, but it turns out that we don't. And we often blame them for that, and we shouldn't. So this is not a talk about using some event sourcing mechanism. This is not even a talk about using OTP, because I like to think that this is a talk about building small things that are really independent. Because I strongly believe that when you have such a system consisting of things that are really small and not coupled with each other, you can have this freedom to change. And when the clients want to change something, or as you want to change something because you start to understand your domain better, you have the ability to do this without making the work harder than it should be. So I chose an example project, and we'll be thinking how to build basically an Airbnb clone. So in this application, we have some person that owns an apartment that is free, and she can basically announce to the world that the apartment is free. Then the guest can look for the apartments, and if they like anyone, they can make a request. They can try to book this apartment. And based on, for example, how long they stay there, the owner can accept this booking or reject them. So how to build this thing? And from my experience on what I have seen in different projects, I think that, and not only our projects as App Unite, but on different blog posts or books, I think the most common approach to build this system would be to start with some apartment context. And you don't really have to read the code, because it doesn't really matter. But in this context, you would have some function to create a new apartment. You would have some other functions to query the existing apartments and return some results based on the query that the user provided. For example, you want to query by location and the price and the number of rooms, etc. So then you would have to make a booking. So you would create a booking context in which you have a function that, as a guest, allows you to send a reservation, to make a reservation. Then you would need a function to reject the reservation as the owner or accept it. And it's quite nice because Elixir is nice and allows us to write this code. But there's a problem, because when you make this thing, when you accept the reservation, a lot of things have to happen. You have to, first of all, notify the guest that his or her reservation has been accepted. You have to transfer the money from the guest account to the owner's account. You have to mark this apartment as taken in this period of time, so it wouldn't appear in the search and it wouldn't be possible to make the reservation again. So you have these connections. And as you can see, there's a lot of coupling, because we made the context connected together. And apart from that, we make multiple contexts, depends on the same data, because now the apartments context have to use the reservations table to filter out the apartments that are taken. So we have this coupling. And most of the people, I think about only one type of coupling, because you have the most obvious one. You may have a dependency on the code itself. But what is often not considered as so bad, but it's there almost all the time, is the coupling on the database. So in our case, we have the booking context writing some data to the reservations table, and the apartment context reading the data. And why is that? And I think that in most of the systems, we have a case when we have few entities, but a lot of different use cases. In our case, we have this basically three entities, because we have the user, we have the apartment, and we have the reservation. But on top of these entities, we build a lot of different use cases. And actually, with each use case, with each requirement, you probably will make these entities bigger. You make this entity more connected with the rest of the system. And this means that when you want to change something, you have to touch multiple parts. And actually, if you look at this example that I showed you before, in the middle, there's a module with a lot of dependencies. And it is, of course, the user schema. So let's try to take a step back and forget about all the things that we know about computer science. Forget about the data and the databases. And try to ask ourselves what is really important. And what is the problem that we are trying to solve. And what is that our users want or our clients want. And let's start with the use cases. So the basic thing that we have to do in our application is to allow users to add the apartments and to search for them. So let's start with that. And let's create some piece of code that is responsible for managing the apartments. So for example, for adding them. And when we want to do this, the user can send a command. Then the command is validated. And if everything is okay, we just publish an event saying that this apartment has been added. And we have the part adding apartments completed, basically. Because now we can, when we want to search for the apartment, we just add another module, another piece of code that subscribes to this event. And every time the event is added, we just update our local state. And the nice thing is that we have single responsibility here. I hope you attended the solid Elixir talk before. So if you did, you know that there are two first rules. We have the single responsibility principle and the open-close principle. And this way we can have both of them, because our apartment management context is responsible only for one thing, and it is really closed for modification. When we want to add a new requirement, a new feature, we just add another code apart from this one that we have already created. So I've said that we publish an event, but what are those? And what purpose do they serve? And events are basically facts. They represent something that has already happened in our system. And that's why they are immutable. Because once something happened, you cannot really undo it. You can publish some other event to update the state, but the fact that something has happened is there to stay. And this is one of the reasons that they are quite easy to understand and to reason about. But the other thing is that they map really closely to the goal that we are trying to accomplish, because they use the same terminology as our clients, as our users. They use the same words that we see in our application. So, for example, we might have an apartment added event. And this is really important, because what the users want to see, that they want to know which apartments were added, and not how we store these apartments in the database. Apart from the events, you have comments that are basically a way of representing the intentions. And they have, because events can have multiple handlers, because when something happens, we might have few different parties interested in this fact. But comments are easy in this case, because they have only one handler, so we always know where these comments should go. And they can be rejected if there's something wrong. So what about the code? Because I showed you these pictures and they were cool, in my opinion, but you obviously want to see some Elixir. And the thing is that it's quite simple, and there isn't much to talk about, because we now have such functions that are just pure logic without any side effect, that take the comment, validate the comment somehow, and if there's something wrong, we return the error, and if there's everything right, we just return the list of events. And this is nice because we have these pure functions that are really easy to understand, that are easy to test, and you can clearly see what are the business rules that you have to follow. And then you just wrap this module in some other module that is basically a public interface. And its only job is to invoke this function. And if there is a list of events returned, it publishes all of them. So then we can see that when we want to search for the apartment, we just handle this event, and we save this information somehow in our own private database. And the nice thing is that previously, when we had this first version of code, every time the apartment was added, we saved it in the database. And it looks unharmful, but actually, when you save this information, when the comment comes, you make a lot of assumptions about what this data is going to be used for. And I often get asked by my coworkers, how should we store this data? Should we normalize them or store, for example, JSON? And I try to always say, well, it depends. How will you use this data? And the nice thing about this approach is that you can decide later. Every time you want to use this data for something, you just write a code that handles some events in the way that makes your task easier. So to sum up the code part, we have pure functions representing the business rules that we have to follow. And this is nice because it gives you all the benefits of functional language. And you have side effects only caused by listening and handling events. So the other use case is that we have to make it possible to make a booking, to book a room. And we do this by creating another piece of software, of code that accepts the command. If everything is right, we just save the information and publish the event. And then, I think you remember, sorry, not this slide. Then we can have some piece of code that notifies the owner. And then when you accept the reservation as an owner, you notify the guest. And this basically solved the problem that we had before. Because now the booking contact is no longer responsible for notifying the guest. It's only responsible for handling the booking. So we can easily add another handler that updates this information. So I've said before that once the booking is accepted, you have to make it so in the search, so the search wouldn't return the taken apartments. And this way it's easy because the apartment search context knows what its job is and can use the data that is flowing through the system to make it useful to use this and to accomplish its goal. So the next part is payments, and it's also easy because it too requires only adding another piece of code that is responsible for payments. And its job is to basically know the data that is used to billing. And every time the booking is accepted, it charges the credit card of the guest. So now instead of this one booking context and this one reservation entity, you have really small parts that are really autonomous, because I've been talking about how the search context have to know which apartments are taken. But the point is that it's not its job to make sure that the apartment won't be booked twice in the same period of time. Its job is to basically ensure that the results won't be returned. But if we mess up this part, and if we return the apartment that is taken, it's the booking context job to ensure that there won't be reservations twice in the same context. So it's nice because it allows you to have all the rules in the one place. You don't rely on the apartment search context to guarantee that the apartments won't be booked again. You have this all business rule in the one booking context. So I like to, basically I read it in some blog post, but I like to, for each part of the system, forget about the data and start with the question, what is the job of this part of the system? And once I know what the job is, I can wonder what data do I need to know to fulfill my responsibility. And only then, when I know which data do I need, I can ask myself, how can I get this data? So, for example, for the apartment management, my job is to verify the comments coming from the user. So the only data that I need is is right there in the code, because I need the rules, and they are encoded in the code itself. As for the apartment search context, I need to know which apartments are available. So I listen for the apartment added event, and I can also listen for the booking accepted event to modify my state. As for the payment context, I have to do the same job. I have to ask myself, what is my responsibility? And the job of the payment context is to transfer the money once the booking is completed. So I have to know how can I charge this money. So I have to know the billing information, and I have to know that the booking was accepted. And I do this by keeping billing information in my entire private state, and I use the event stream and use the events to know when to actually bill this person. So what about the PubSub? Because in my talk's description there was a part about building the PubSub system in Elixir using the gen server and message passing. But actually, what I would recommend you to do if you want to start is to use something like that. We just, every time we publish an event, we take the static list of handlers from the config and just invoke a handle event function on all of them. It's fully synchronous, so you don't have to deal with all the problem with asynchronous message passing, but it can have its own problems. So if you need something that is asynchronous, you can basically use the new, not so new actually, registry and its dispatcher functionality to dispatch the events to different processes. But as I've said, this doesn't really matter, because I strongly believe that if you want to use events to model your system, you have to start with the good domain design first, and only there start to solve all the problems with how to actually deliver the events. And this is the part that I would really love to talk about with you, but maybe after the talk. And of course, if you need, you can use something else like Kafka, like RabbitMQ as your event stream. You can use the knowledge that we learned today at the keynote to build some task system and use that. But the important thing is to model the domain first. And one more thing that I would like to tackle is the don't repeat yourself rule, because it's one of the most popular rules in our case, and it tells you that you shouldn't have any duplication, that every part of the system should have only one representation. And if you look at the diagram, you see that we have the application. We have the same information about bookings in the two databases. So why? And I think that the important part, and the part that is often overlooked, is to understand what each rule that we know is trying to accomplish, and what this rule is trying to prevent us from doing. And if we try to look closer, we see that don't repeat yourself rule is about eliminating the need of having to change different parts of the system when something changes. And when you look even closer, you can find the content that is saying that, that it's okay to have a textual mechanical representation as long as you know which source of the truth is actually the main one, and where you can go and look for the true information. And in this part, it's important to understand what we are doing. And the data used by the apartment search context is used only to ensure that the results don't contain apartments that are taken. And that's why it's not a source of truth, because even if we don't have this information, the system will still work fine according to the business rule, because the booking context will prevent the user from booking twice. So this part is actually something like a cache that allows you to do your job, but it's not necessary. And the nice thing is that at the beginning, we can start with one database, and we can use one Postgres database to basically use it in all of our contexts. But then our system can grow, and it might turn out that we need to scale somehow. So we can take this apartment search database and scale it. You can use, for example, sharding to have apartments from different regions handled by different databases. You can decide that Postgres is not longer enough and use something like Elasticsearch. And we see that sometimes having this duplication allows us to change easily, and allows us to basically change only one part without affecting the other. So, to sum up, I think this approach has a lot of benefits because it helps you create parts of the software that are really small, really focused, and autonomous. It reduces coupling between different parts of the system because they don't rely on their internal representation. This approach creates better boundaries between the systems and between the components, which is quite nice when you have to change. And this approach is actually more scalable because if you do this right, you can basically take these parts and extract them out of the monolith, put them into a separate release, and scale it accordingly. Of course, you would have to switch the synchronous pops up with something like message queue, but it's fine, and you can easily do this. And it's also easy to change, and this was my goal from the beginning, to find a way that would allow me to change my software easier, to adjust to the needs of my client, my users. So I think it's doing a good job. Of course, any approach has its drawbacks, and it's not the exception. So it requires some more work because you have this duplication sometimes. You have to do a more initial work to make this happen. So it may not always be worth it, and you have to consider if you need it and if it would help you. It also introduces something less familiar, so you may have to take some time to adjust. But actually, when I talk to new team members that are coming to the project, are seeing these events, their opinion is actually quite nice because they have this small part of the system that is responsible for one thing only. So they need to just know the events and hear what they need to do, and they can do this easily. And if you take this approach and you scale it and you start to use message passing, you start to use Kafka or RabbitMQ, you would probably have to deal with message loss. You have to deal with events being delivered more than once. So you would also have eventual consistency. So it's a bit harder, but at least you have this separation because you have, on the one hand, you have the domain model and its problems. On the other hand, you have the problems with message loss, and you can tackle this problem separately. And one thing that is hard, and there's not a lot of resources, is how to use event versioning, because when you scale, when you actually use microservices, you have to think about different versions of the system running and what happens if some old part of the code sees a new event. And this can be quite challenging. And one more thing is that you would have to, if your team is big enough and if your system is big enough, you have to find a way to somehow share the knowledge about the events in your system, so the other parts of the team can do its job. But like I've said, all approaches have their drawbacks. It's not the exception, so you have to deal with that somehow. But there's more. As I've said, you can use event sourcing to basically make the event log the source of truth, which has a lot of nice benefits. You can use this approach to build microservices. You have a lot of different storage options, and this is the topic that is really interesting in terms of the Erlang and Elixir ecosystem, because you can use database, but you can just as well use plain files to store some information, and this is actually nice and actually can improve your system and make it a lot simpler. Oh, sorry for that. You said that I shouldn't touch this button. I would like you to think about behavior and not to focus on the details, because we often start with when we want to accomplish some goal, we often start with the database schema. And I think it's wrong, and it leads to different problems that can be solved when you try to put yourself in the user's perspective and think about the problems that you are trying to solve. So as I've said, for each part of the code that you are writing, think about what is the responsibility of this part. Only then think about the data. Only then think about the source of this data, because it's much more important than the representation of this data, because users don't care about the way that you store data. They care about what is happening. And the last thing, use your tools wisely, and don't focus on the rules, because when you try to read about event sourcing, when you try to read about using event sourcing with CQRS, when you try to read about microservices, you see a lot of people giving you these hard rules that you have to follow. I think it's not a good idea. Focus on your users, and I think when you do that, you will make yourself a much better developer, you will make the project better, and you will be much happier. Thank you.
Okay. Anyone got a question?
Hi, thanks for your talk. I wanted to ask about the event model and the decoupling part, where after successful booking, there were 3 things that we needed to do: the notification, then the payment. So what happens, for example, if they are actually coupled? For example, if the payment fails, we need to cancel the booking. So does it mean that this event model will be much more complicated, or do you think that in such cases should we actually take it like in one module?
Yeah, I actually hoped that someone asked the question about the payments, because the truth is that there is no good answer, because the way that you handle this case depends on the business model. It depends on the user experience that you would like to have in your application. So for example, you may have a requirement to charge the credit card and return the error right away. You may have, for example, some discount codes that would make it possible to always succeed. But One solution, for example, to what you've said about that you would have to return an error, would be to not notify everyone when the booking is accepted, but notify them only when the booking is accepted and the payment is done. So it actually works quite nicely because it is now the requirement that you have. So you have, sorry, that's hard. You don't send a notification when the booking is accepted, but you send when the payment is done. And this is your business rule. And I think it maps quite nicely. And as I've said, there's no one right answer, because it all depends on the business requirements that you have.
Any more? Nobody got a question? Come on, got a bit of time. Okay, round of applause, thank you.